Good day. Again, I'm back as promised. This is Bongan Masango, your tutor. Today we'll be looking at the empirical formula. Please, guys, don't forget to subscribe, and it's free of charge. All right. So we are going to look at the empirical formula, which is the simplest whole number ratio of atoms in a compound. Okay. It might sound tricky, but it's not. Just look at the following example. We say it's compound X2O4P6. All right. This is what we call a molecular formula, where it indicates the total number of atoms of each atom in a compound. All right. What is the simplest form, okay, of this molecular formula? Right. We can see that 2 can divide into these atoms. If we divide by 2, then what are we going to have? We're going to have X. From O4, we are going to have O2. From P6, we are going to have P3. This is what we call the empirical formula, and it's what we'll be doing today. All right. So, how do we calculate the empirical formula? To calculate the empirical formula, you consider 100 grams of the compound. Take each percentage as the mass of the element in 100 grams. So they are going to probably give you percentages, 50% of these, 25% of these. You change that to grams. Okay, so instead of 50%, you write 50 grams so that you can find the number of moles. All right, the next step, you find the number of moles of each atom. We know number of moles is mass, which you would be given, right? And then mass over molar mass of that specific element. Okay, after finding the number of moles, you'll have the number of moles for those elements. You divide all elements now, or moles, with the smallest number of moles. Okay, so with the smallest number of moles that you got, you divide all of them. If there are 3, you divide 3 of them, okay, to give you a whole number. Okay, sometimes it happens that you don't get a whole number. What do you do in that case? If you don't get a whole number, you multiply the values that you got. Okay, maybe you got 5.3 or 5.7, 5.8. It's still not a whole number. When you multiply by 2, if it doesn't give you a whole number, you multiply by 3 and so forth until you get the whole number. All right. And then write the empirical formula. All right, so you're going to write the empirical formula, but I want us to do this together. Okay, first example. Okay, there we go. Can you see that? Yes. Okay, this is a worked example. Now, a compound contains 52.2% of carbon and 13.0% hydrogen and 34.8% of oxygen. Determine the empirical formula. Okay, what are you given? You're actually given carbon, you are given hydrogen, you are given also oxygen. Okay, if you write it in that order, you are not going to get confused at all. So now you are given the mass. Remember, for carbon, you have 52.2 grams. You change the percentage to grams, and then you are looking for the number of moles of carbon, which you divide by 12. Yes, grams per mole. Okay, so that is for what? This is for carbon. Okay, then you need to do for hydrogen, which is 13.0 grams. You change the percentage to grams, divide by 1 grams per mole. Okay, let's go to oxygen. Oxygen, you have 34.8%. You change it to grams, you divide by, oxygen is 16 grams per mole. Okay, and then you are going to use your calculator there. 52.2 divided by 12, you are going to get 4.35. What is this? Obviously gram and gram, okay, cancel out, and then per mole becomes mole. So you are going to get mole. Please make sure you write mole here. I mark learners wrong for not using mole here. All right, this is going to be 13.0 mole. Okay, and then here we are going to get 2.175 mole. And the next instruction says what? Divide with the smallest mole. Okay, hope you guys can see. Sorry about that. Divide with the smallest mole. Which one is the smallest here? It is 2.175 mole. Yes, 2.175 mole. So you divide everything with the smallest mole. Okay. All right. And then what are you going to get there? Okay. All right. What are you going to get? You are going to get 2. Okay. You are going to get 5.99. Let me write it for now. I want to show you something. And then what are you going to get here? 1. Okay. Guys, you can see this is 2. 5.99, that's 6, guys. That's 6, but 5.82, it's not 6. Okay. 5.99, it's 6. Okay. Even 6.02, it's 6. Okay, so you are going to have 6 and then 1. Therefore, this 2 belongs to what? Carbon. There we go. So we've got 2 carbon atoms. This 6 belongs to hydrogen. You have 6 hydrogen atoms. This 1 belongs to oxygen. There we go. This is your empirical formula. Okay. All right. I hope that was not difficult. Can we do something else? Definitely. All right. Let's get another question. Let me see if I can get another question for you. Okay. Seems as if I don't have questions. Okay, let's write this question down. Let's write this question down. Determine the empirical formula. Can you see there? Can you see there? Yes. Okay. Practice question. Okay. So it says determine the empirical formula the empirical formula of a compound containing containing 48.6% of carbon, 8.1% of hydrogen, and 43.3% of oxygen. Okay, Now remember guys, this is per 100 grams. So in other words, it means when you add these percentages, they'll give you 100. Okay, but anyway, let's look at it. The first one is carbon. The next one is hydrogen. And the following one is, where is it? It's carbon, hydrogen, and oxygen. All right. Can you see? Yes, you can see. You can see. Now, carbon, we are given 48.6 grams. Hydrogen, we are given 8.1 grams. Remember, you change the percentages to grams. Oxygen, we are given 43.3 grams. Okay, yeah, I forgot to say you can pause this video and try it out. Okay, so and then let's work it out. We are going to divide by 12, divide by 1. Okay, well, grams per mole, 1 grams per mole, 1 gram per mole, and then this is 16 grams per mole. Okay, you know this will cancel out and you'll have mole. Okay, so 48.6 you divide by 12, I get 4.05 mole. Okay, this is going to be 8.1 mole. Okay, and then I'm going to get 2.706. okay, mole. Okay, now you check the smallest. Okay, you can see it's going to be 2.706 mole, 2.706 mole, 2.706 mole. Okay, when you divide the two, you are going to get I get 1.496. That's a ratio now, it's no longer mole. Okay, that's a ratio. And then I get 8.1 over 2.706. I get 2.99. Okay, and I get 1 here. Okay, can you see that this is 1.496? This is not 2, guys. And then this is 3, this is 1. So we have a challenge. All right, so we must multiply everything by 2. Okay, when we multiply by 2, 1.496 multiply by 2, it becomes 2.99. okay, and then this multiplied by 2 becomes 6. 1 multiplied by 2, it becomes 2. Okay, and you see that this is now 3, guys. It's 3. So we have 3, we have 6, we have 2. Okay, and therefore the 3 belongs to carbon. 3 carbon atoms and the H. All right, 6, and then 2 belongs to oxygen. That's your empirical formula. You don't have to write empirical formula. Okay, so I'm just showing you that's your empirical formula. Okay, all right. I want to look at because I see time, so now site, I wanted to look at the molecular formula. Okay, molecular formula. Okay, let me put this here and talk about the molecular formula so that we can do this once and for all. Molecular formula. Okay, now we said the molecular formula is simply, it's going to show you the number or the total number of atoms in a compound. Okay, so you are going to get the total number of elements in that specific compound that we'll be talking about. Okay, so I'm looking for an example here that has the molecular formula. I'm not getting a question. Let's see. Okay. There we go. There we go. Let's say you are given the empirical formula. Okay. The empirical formula is given to you. Is given as CH2O. Can you see there? Okay, I hope you can. Okay, I hope you can. Okay, you are given the empirical formula to be CH2O, and then the question says find the molecular formula. Find the molecular formula, all right, that has what is this? 30 grams per mole. Find the molecular formula that has the molar mass, okay, the molar mass of the empirical formula, of the molecular, is given to be 60,06 grams. Okay, right, grams per mole. So you are given the molecular formula and you are asked, okay, you are asked to find the molecular formula of what? Of CH2, okay, between CH2 and the molar mass that is given to you. Okay, so in fact, you are looking for the molecular formula, and they've provided the molar mass of the molecular formula. Okay, let me repeat that. Okay, because my words are all over the air now. You are going to look for the molecular formula, okay, of a certain compound, which is this one, okay, given the empirical formula, all right, and the molar mass of the molecular formula. So the molar mass you are given for the molecular formula you are looking for, okay, and the empirical formula is the one that you normally work out. All right, there's no formula, guys, but I can say you need to find the ratio, all right, which will be the molar mass of the molecular formula. Well, there's no formula for it, over the molar mass of the empirical formula. Okay, so what is the molar mass of the molecular formula? It's given to be 60,06. What is the molar mass of the empirical formula? This empirical formula, it is 12 plus 2, 14 plus 16. That's 30, guys. Okay, so you are going to have the 2, you're going to divide the 2, and then, well, we know this is grams per mole. This is grams per mole. Well, it's not really a problem. You're going to get a ratio here, and then the ratio will be 2. Okay, and then when you take that 2, multiply into your molecular formula, okay, well, you are going to get the, into your empirical formula, you're going to get C2H4O2. Okay, so actually before it was simplified, it looked like this. Okay, and then that's when you got your empirical formula, because It's the simplest form of this. Okay, that's what it actually means. So the molecular formula of this empirical formula is C2H4O2. Okay, so yeah, I wanted to add that because I saw